In this video, we'll be talking about the analytical methods in which we evaluate limits. In this case, the first limit we'll be looking at is the limit as x approaches 1 of 2x plus 5. Recall the general definition of a limit in terms of as x approaches 1, the limit wants to determine what does the behavior of the graph appear to do as we get closer and closer to that x value. Well, given that we have a function 2x plus 5 and plugging in the value of 1 doesn't seem like it's going to cause any issues, and we should assume that because this is a simple linear function, there should be no problems in actually assuming that the function is going to do what it appears to do at the value of 1. So, the most basic method in which we evaluate limits is by attempting to plug in the value for x. In this case, as I plug in x equals 1 to the function, I end up with 2 times the value of 1 plus 5, and therefore this limit is equivalent to the value of 7. The second limit we might look at is the limit as x approaches 1 of x minus 1 divided by x squared minus 1. However, in this case, when you attempt to plug in 1, and again, this is the first basic method, is plugging in the value of 1, you'll notice we'll get 1 minus 1 divided by 1 squared minus 1, which is actually 0 divided by 0. And we should all know that 0 divided by 0 is not a value we are allowed to determine in any way. The fact that it's divided by 0 causes all sorts of mathematical issues. So plugging in 1 in this particular case doesn't work. However, there are algebraic methods in which we could manipulate and simplify this function such that the behavior of this function near 1 will be the same as the behavior of the simplified function that we look at. So in this case, what I can do is inside of the limit, making sure that I don't eliminate the limit, I'm going to go ahead and factor everything that I can, in which case the bottom becomes x minus 1, x plus 1. And you'll notice then that on top and on bottom I have this x minus 1 term. This x minus 1 term can cancel out, causing me to have the limit as x approaches 1 of the constant on top is 1 now, because again everything was canceled out, divided by x plus 1 in the denominator. Now if I were to attempt to try and plug 1 in, you'll notice I get 1 divided by 1 plus 1. This then causes me to have the function value of 1/2. So you'll notice here that the basic method of evaluating limit is to attempt to plug in the number that you're given for x approaching. If that number can be plugged in, you will eventually get the number we're looking for as the limit value. Down here, if it doesn't simply plug in, attempt to try and factor. That is the first basic method of evaluating limit, is factoring. After factoring the limit, we can go ahead and plug the number in because the behavior of this function here near 1 should be the behavior of this function here near 1. At 1, we don't have equivalence. Again, at 1, as I plug in 1 here and as I plug in 1 here, these are two different functions. But they behave exactly the same way around 1. So as x gets closer to 1 of this function, it's going to be the same as x getting closer to 1 on this function, and therefore we have the limit value of 1/2.